Now that the projects I had recently have ended, it's now time to step back and take a look at the STOE and see what we should be doing next. First, let's have a review. The Scalar Theory of Everything, or my STOE, is a causative and Machian model. It reduces to general relativity and quantum mechanics with the appropriate assumptions. It explains many problematic observations. Indeed, explaining those observations has been the papers that I've written. It has made some predictions which later were found to be true. It rejects the experiments of Maxwell's equation by experiment. It rejects wave models of light, and it doesn't use Lagrangian and Hamiltonian mechanics because they don't include dissipative type energy. The start of the STOE began with Newton's path, that is, say, his optics queries. It then went to the quasi-steady state cosmology, and you can see here a book which describes that model. The QSSC suggested a source of the stuff of our universe at the center of galaxies. It solved the rotation curves of spiral galaxies and other spiral galaxy problems. The STOE added to the QSSC, plenum and HODs are the only components of the universe. The plenum is a continuous substance which supports wave action, and the HODs are small two-dimensional magnets, as we now currently think, which then end up making up matter. The HODs and plenum then emerge to form everything else in the universe. They come from sources at the center of spiral galaxies and go to sinks at the center of elliptical galaxies. Here is a summary paper. And of course, there's the YouTube video, which kind of summarizes the STOE so far to date. Now, in the STOE, the galaxy cluster is the unit that makes up the universe. It consists of spiral galaxies, which are sources, and then elliptical galaxies, which are sinks of the stuff of the universe. And here you see the paths that various elements follow. You can see a description of these galaxies, spiral galaxies, elliptical galaxies, in Binney and Merrifield. This then is the view of a galaxy cluster. You basically have spiral galaxies around elliptical galaxies. The stuff of the universe comes from these spiral galaxies and goes into these elliptical galaxies. This gives a flat universe, meaning Euclidean, with a boundary. The STOE uses the heat equation as a source of the stuff of the universe. That is to say, in the universe, there are sources and sinks, and the energy comes from sources. And here we have a typical heat equation where U then is the temperature. This was used to calculate the theoretical temperature of the microwave background, and there's the paper down below. The temperature is actually analogous to Blenheim density, which we symbolize with rho, so that the force, which is del rho of gravity, is like temperature or heat flow. You'll note that in the STOE, the universe is not commutative. That is to say, your father was born before you were. So using math operations such as addition, you have to be a little careful about making sure that you're not violating the commutative requirement. This is the cause and effect argument. Entropy in the arrow of time is that the arrow of time is from sources to sinks, and matter flows that way. And therefore, entropy, because you have sinks, the entropy must include some kind of dissipative function, which turns out to be entropy. Uh, the universe, therefore, is not a closed system. That is to say, it violates the first law of thermodynamics. Energy is created and destroyed in the STOE, but the long-term average may remain the same, and therefore entropy may actually be relatively constant, oscillating about some fixed value. This is the universal equations for the STOE. This is the plenum density. Here is the contribution to the plenum density from all sources in the universe, from all sinks in the universe, which kind of takes matter and energy away, and of course, all matter in the universe. The plenum density, the gradient of the plenum density, then is a force which moves things around. You'll notice we have a spherical principle which derives from using the heat equation for sources and sinks, and of course for matter. There is only one force in the STOE, the del rho, not 4. I would note here that we have chosen the magnetic form of the HOD because that neatly gets rid of trying to account for the weak and strong force. The concept of the weak and strong force resulted from considering the proton as having some kind of intrinsic charge, and therefore you needed something to hold the nucleus together. Well, in the STOE, we don't have the charge holding the nucleus together. The protons are magnetic, and therefore they are held together without needing to some kind of complex weak and strong force. The first two terms, which are the sources and sinks, uses the spherical principle, which of course derives from using the heat equation for energy. The rho solved many cosmological problems, including the C&B temperature rotation curve, asymmetric rotation curve, central mass versus central velocity, etc. The third term, included with the first two terms, then solves the Pioneer anomaly in the Planet 9, where there is only one source, that is to say, the Milky Way source, and the rest of the sources and mass of the universe provide some constant background rho value. The last term, this one, this is the problem. This isn't quite correct. This part of the problem was derived in trying to describe photon interference. That is to say, photon is a particle, and we want to have it do interference. This works for Young's experiment, the Ashfar experiment, and the transparent mass experiment. But still, it doesn't quite do too well within an atom, meaning subatomic particles and the like. So there has to be some modification here. The challenge is to essentially figure out what that third term has to be. We consider the plenum to be superluminal, and it's generated by a moving HOD, but the HOD has a magnetic leaves the quandary of how the moving magnet generates such a wave. I'm currently thinking the HOD is a magnet with north and south poles. Experiments with magnets suggest an imbalance in the north and south pole strength, which produces gravity. Electric fields in the STOE are produced by HOD movement. Thus, a Helmholtz decomposition, which has been suggested, may suggest a description of the magnetic field and yield a description of the structure of subatomic particles. I had considered an alternate model years ago with the HOD holding an intrinsic electrical charge, which then rotated to form the magnetic moment axis. This, of course, leaves the observation of asymmetry unexplained and results in needing the strong and the weak forces. The PDP matrix has been suggested with 4 tensor fields. Two are north and south poles of a magnetic field, that is, say, the Hod. The other two may be time variation of the magnetic field, that is to say, the moving Hod. And this is Maxwell's electric field, and there's the paper describing the PDP matrix. In this interpretation, the psi, which is a wave function, is a real wave in the plenum. It is generated by a moving Hod, as per Maxwell's equation. The EM field, such as a radio signal, is moving Hods traveling at the speed of light. And this model was advanced in looking at some Boyer-Savart law experiments, which is, here's the paper. So we're suggesting that the magnetic field near a Hod, like a disk magnet, and here we see streamlines representing the magnetic field, and very close to the magnet, the streamlines are all parallel, and the force, the gradient, is inversely to distance. Not distance squared, just distance. This is kind of like a field, the electric field in between capacitor plates. Further on, the magnetic field becomes dispersed in that it becomes inverse distance squared somewhere perpendicular to the Hod surface. Now, this is not a typical spherical principle kind of inverse distance squared. Therefore, there must be some force, some gradient that is causing the plenum density to vary along the equal potential surface. And you see the other side of the Hod, the magnetic lines are coming into the Hod. So basically, this was published in a fourth paper having to do with the gravity field from magnet to match the data that I was getting. And this is a function which seems to work. This is the conjugate function. And here is the magnetic lines of force coming out. They're parallel initially, and then they expand outward. And this is the equation turns into just a bunch of parallel lines. And this is much easier to deal with. Now, of course, this would be one pole. The other pole would be on the other side, and the lines would be coming back in here. This is the kind of equation that's used to look at the flow of a liquid out of a channel into an open sea, or an electrostatic field at the edge of a parallel plate capacitor. So the concept here, the potential from a Hod is quite easy. All you have to do is figure out what the distance is, and then how far off the axis it is, and you've got it. But then you got to do the inverse transformation to figure out what the strength is at some, the strength of the plenum is at some distance. The Hods disappear. That is to say, they're all 2D, and all is plenum. And the plenum is inertial and superluminous, as we mentioned before. So this should be able to be handled. So the center of the coordinate system should be the center of one Hod with other Hods, circle planes with north-south poles, which are also added to the plenum density. If a distance between two Hods become close, the force is inverse distance, which the previous procedure will show, and the Hods combine to form a long magnet, which would be a photon, and then the photon go on to form other particles. Gravity is because there's an asymmetry in the pole strengths that we found. And here's the paper. So you have those kind of streamlines which go from one side of the Hod to the other through the plenum, and the force is by these arrows, but since this side here is stronger, the asymmetry and the pole strength, this turns out to be gravity. So we have one force account for all of the four forces. That is, gravity here needs a certain size, that size being greater than the size of an atom. One of the papers that I wrote detailed what an atom was using magnetics only, so that the photons are kind of like are holding the electrons away from the nucleus. For distances less than the atom, the del rho is magnetic and gravity just doesn't apply. Does gravity entangle? In the STOE, gravity needs to entangle. That's to say, the superluminal speed of the photon changes, of the plenum changes, does then entangle, but this is not in the quantum realm. Observation is gravity acts as inverse square of the distance from the center of mass. That is to say, when you get a certain size, the sidewards pressure of the plenum kind of evens all out, and the spherical principle then starts to apply. The spherical principle. If you have a point of the source of the stuff, such as light, matter, radiating outwards uniformly in all directions, which is what we assume for the sources and sinks in the universe, this stuff gives a surface density of inverse distance squared. So the force is a gradient effect on the surface of a test body. And here's a little diagram. You see how that is. You have a uniform source, and as you go with distance, the density here is going down by inverse square of r. But of course, as I mentioned before, this produces a problem here where you've got to have some kind of evening along the equal potential surface to yield the inverse distance squared. When you apply this to gravity, you've got to have the force, that is to say, the del rho acting on the surface, not on a body, but yet it appears as though the whole body in Newton's time was needed to describe gravity. So this force, the del rho, then is on the surface of Hods, which then make up the body, if you see what's going on here. And that's what we suggested in the STOE photon interference computer simulation, which worked. Next, the STOE considers strong causation. And here we have a paper where this idea of strong causation is presented. What strong causation is our everyday sense of cause and effect. It is much stronger than many causation models that use mere causal order. That is to say, you observe one thing happens after another. What we're going to say in the STOE is that the world is much stronger than that. It is one thing causes another, always. And the physics models should incorporate that cause. However, in this, what strong causation is that a signal in the plenum needs to be emitted by the Hods as they move through a plenum to affect another Hod. So it's Hod to plenum to Hod, as you see here. And since the plenum wave speed is superluminal, all interactions are superluminal. And of course, strong causation requires asymmetry. Now, time in the STOE is duration between events. Time is not a dimension in the STOE. And this is kind of subtle because many people, they just put t out there and they consider it a dimension. But if it's only duration between events, then you have one thing following another from source to sink. You know, that is to say, you don't have the possibility of going backwards in time. That one event follows another, and that's it. You can't have the time reversal is not a part of physics. Further, all causation involves some energy transfer which goes to entropy. That is to say, it's wasted in the universe, and this is not recovered. And that's what makes the physics equations not time reversible. That is to say, you've got to put energy back in, but then putting energy back in is another act. It's another experiment. So the Hamiltonian or Lagrangian math is problematic for STOE dissipation. However, if HODs are separated, the speed of the plenum cause may suggest a different causal order to different observers. And this is why causal order is too weak here. Some observers may actually observe because of the speed of the wave in the plenum, just like light speed may actually have different order of events. For example, in the typical special relativity thing of a ladder going into a barn, it's possible to observe that the ladder compresses so it stays in the barn, whereas another observer might see the ladder coming out of the barn and therefore not changing its length. That's a problem of causal order. Of course, the STOE accepts only strong causation, and that kind of thing is simply accounted for because of the speed of the connecting wave in the plenum or the speed of the light. For example, consider the Maxwell-Faraday equation. In stated physics, this is merely a law of association. That is to say, it could occur in either direction. But in the STOE, the time-varying magnetic field is a strong cause, and that causes the E field, not the other way around. Indeed, this may be the origin of the E field, which is the entropy into the plenum. In the STOE, one thing that we can explore is how do we get the subatomic particles? We could consider a spherical volume and theoretically place HODs, this is mathematically, in with random orientation such that they are far apart, then shrink the volume. This is the suggested way that the stuff of the universe, HODs and plenum, come into the universe through sources. They then combine as they drift away from the source, that is to say, as the local plenum density goes down, they then combine and they form subatomic particles, then hydrogen, and hydrogen then goes out from the center of the galaxy. The volume is the smallest volume that a given structure occupies, and therefore, as you shrink the volume, you then form these structures. Remember, so far in the STOE, we looked at stable magnetic structures, which are the photon, the neutrino, the electron, and the proton. And this is all getting the distance very small, where when one magnet was next to the next, its distance was such that the force was 1 over d, not 1 over d squared. Now, how to do this is kind of an issue. One of the things I experimented with was dropping magnets, put them together in a ball, such as we've suggested as a proton, and then dropping them as a matter of collision and see what comes out. But that didn't work because it broke the magnet. So, The strong equivalence principle. This is a general relativity kind of thought experiment where you have a rocket accelerating and you compare the acceleration in the rocket to gravity, and you consider that to be strong equivalence principle. Now, the STOE relates this to the Michelson-Morley experiment, which we say in the paper that talks about replacing special relativity. In the STOE, the local rocket mass determines the plenum variation, and that's what we found was true in the Michelson-Morley experiment. Let us say the room the experiment was done in, the big mass the experiment was done on, the table, determined, along with the sun and the moon, determined the results of the Michelson-Morley experiment. This is what was happening, and I call this carried along. The Fitzhugh experiment does the same kind of thing. In air, in table, you have atoms which are then modifying on a very small scale the plenum density between the atoms, and those photons that are on the higher plenum density are going faster than those at the low end of the plenum density, like you see here. And this is what, in the computer simulation, gave coherence from incoherent light. And this was done in the computer simulation. As you see here, that was the model. So if you take a rocket, general relativity suggests that it's the same as in gravity. Now, this is not true. In a rocket, you have, across the entire width of the rocket, you have then a fairly constant and parallel force of gravity, force of the rocket. However, gravity doesn't act that way. Gravity has tidal forces that say it acts as if it's from a center of some mass. So the problem with the rocket is that these two force fields from the gravity or from the rocket are different, but we just can't measure that difference because the distance is so small. But in the STOE, we have the Fitzhugh experiment carry along kind of thing, which means that it's the matter of the rocket only if you're outside of a strong gravitational field, and therefore you will see the light just go straight across the rocket if there's no other really strong magnetic or strong field in the area, such as suns or moons or Earths, etc. So the strong equivalence principle is simply not true in the STOE. There's a problem, it seems to me. Both of these models consider that mass, bodies, depresses space-time, or in Newton time, it would be as ether, that it depresses some value of ether. Now, where did that level of stuff come from? In some analogies, you have a rubber sheet, you drop a ball in it, and it depresses the matter. But where did the value come from of that rubber sheet? That stuff must come from someplace, and it must be a component of the universe. Well, the STOE says that stuff comes through sources and goes out through sinks. In general relativity, there are some models which say that space-time stuff that is being depressed was there before the Big Bang at some level. And therefore, when matter come into the universe, it has depressed it. Now, this implies that the speed of light varies and the constants are not constant because this overall level is being decreased. These models, and there are several of them, are very complex. And that's probably why it's not being pushed too much. The other approach in general relativity is simply to ignore the issue that that level is there and there's no accounting for it. Both results in very complex, non-Machian models. And of course, this leads to many ad hoc postulates in those models. The STOE has a plenum level coming from all sources and sinks and matter in the universe. And of course, a piece of matter then depresses that max level. And that is in all the data that we looked at. Now, what happens if you look at this maximum rho in different areas where the level of maximum rho may be different? You know, close to masses, away from masses, etc. Here's a piece of matter at a given r in both cases. And what you see here is, if you look right here and just mark, you see that the slope here, which is the force, is different depending on that level. You see? So the gravitational constant depends on the maximum rho level that is in the area. Now, that maximum rho level can change, you see. And in fact, when we looked at the Pioneer anomaly, we saw that it changed because of the source at the center of our Milky Way changed very slightly and hardly had any influence at all, although it was measured on the Pioneer anomaly. However, if you go to slightly greater area than our size of our solar system, this became the Planet 9 observations. In the Pioneer anomaly paper, we noted that the orbit of Pluto was such that this change in rho accounted for a difference of force on Pluto compared to the planets closer in than Neptune. So the constants of the universe, gravity, the variable speed of light, and the variable gravitational constant and Mach principle are all related to varying plenum density. Therefore, all the constants of the universe are related to varying rho, and therefore they vary. So, in various hypotheses, you find Dirac's hypothesis, where you have various ratios which seem to be a number that must be the same throughout the universe. But you'll note that the gravitational constant compared to the varying speed of light, both of them vary depending on the rho. So G over C is simply the ratio of their proportionality constants, and this doesn't vary. In the STOE, the mass of a particle divided by the photoelectric effect, the slope of the graph was h. So that slope means that the addition of one extra Hod to a mass body is h, and therefore h is the energy of one Hod, and m over h is then the number of Hods composing a particle. And that, of course, would be the same. Now, this is not quite true for an electron, because as we saw in the atomic structure, the electron can have some whiskers associated with being in an atomic structure. So the alpha, the fine structure constant, may vary slightly with temperature and what its condition, how far the electron is from the nucleus. So the constants in our strong causation model results from negative feedback loops. And here you see that being applied to the C and B radiation temperature. We could also apply the redshift equation to the Pound-Reeve experiment. Z has already been applied to the Pioneer anomaly, all 10 of the anomalies, whereas the standard model only applies to one of the anomalies, which means it's not that good of a model. This model made predictions which were later confirmed to be true. We could apply the photon simulation to reflection, refraction, and the quantum eraser experiments. This has several problems associated with it. But maybe what we could do is redo with the length of the plenum wave as a function of the number of HODs in the photon, rather than using the model of linear dipole antennas. Now, Bohm's has suggested a point particle, and the STOE doesn't accept point particles, it accepts some extended space. And we could do this rather than indirectly, as the photon simulation currently suggests, as a body with volume rather than a point. I would note something of interest here, and that is these Walker experiments, which use only one drop to make waves, which then cause diffraction when going through a slit. This is why we might look at the length of the plenum wave concerning with the mass of the photons. It may be easier with this to consider reflection. We could apply the rotation curve equation to spiral galaxy orientations. Recently, some papers over the last 5 years or so have noted correlation of spiral galaxy disk orientation in space being somewhat related to their neighbor's position. Now, the asymmetry of the rotation curve was considered, and it considered these neighbor galaxies, and so this spiral galaxy rotation orientation may be considered a prediction of the standard scalar model. This is the issue that we have. Currently, where here you have rotation velocity squared compared to all these galaxies and versus B-band luminosity. Now, you'll note that there seems to be several relations. The slope of each of these lines is twice the previous line. And this area in between the lines is actually a void area. Now, the slope of the lines differ by approximately 2, and statistically, the form is significant by rejection of the null hypothesis that the data points are random. What galaxy characteristic does the B-band luminosity depend? That's the problem. If we could find that, maybe we could have just one nice line in the previous graph. That would also apply for central mass, which was another paper. Another effect of the source at the center of Milky Way we could look for. We've already applied it to RCs, as we said. Planet 9, there's 2 papers on that. Mercury and other planet orbits seem to have some relation to the source in our Milky Way. And of course, the source in our Milky Way was part of the Pioneer anomaly paper. We could expand the idea of structure of particles being like disk magnets to quarks. What that structure is appears to be that it's going to be like electrons being held together by photons is what it looks like. But, I've yet to come up with a structure. I could form a ball of disk magnets, which would be a nucleon, such as a proton and neutron, and do collision experiments but the using of ball disk magnets didn't work, so perhaps disk magnets would work. We could look for a method to measure the speed of the magnetic force. Now, in the STOE, that would be the permanent magnet force, not the electromagnetic force. The STOE found that these 2 kinds of magnetic forces of Maxwell's equations are different. Now, one of them, the electromagnetic force, appears to be producing the electromagnetic waves would travel at the speed of light, and that is the speed of Hodds. DeSangro and others looked at the speed of a Coulomb force and found it to be many times that the speed of light. And the STOE would suspect that the speed of the permanent magnetic force would be a plenum thing, and therefore would have a very high speed relative to the speed of light. The trouble is finding a way to measure that. Consciousness is something I think about for a while, but I think before the industry can go forward, it has to define just exactly what consciousness is. And that, of course, is lacking in today's discussions. STOE views life and societies as part of our universe. Therefore, the basic postulates of physics should also apply to life and societies. And I looked at that in this paper. But of course, the reverse is also true. That is to say, the characteristics of life and should also apply in physics. That is to say, life expands by means of giving birth. And so there must be a form of birth in physics, which the STOE looks at. In the STOE, I looked at emergent characteristics, and these are a little different than what most people mean by emergence. But if we apply consciousness to the STOE, it could be an emergent characteristic, which means human and animal and plant emergent characteristics, or it could be present in all objects in the universe, such as rocks. Now, this has once been suggested by ancient Greek philosophers when they noted that objects, meaning rocks, tend to find their natural place in the universe. That means they have to know where their natural place is, and also in the view of where Hades is compared to heaven, meaning heaven is up and Hades is down into earth, because the earth was considered at the center of the universe, at the center, but not the center, because all Earth is a gravitron. Oh, well, enough of that. Current approaches tend to view the brain as a digital computer for processing and collating information. Now, the STOE approach might be very different from that. It could view the brain as an analog mechanism. Therefore, it can have a great many more levels per given unit of time, which means a great many more digital processing rates. We could also, something I've been working on for quite a while, is to consider a third U.S. Constitution. Humanity seems to lack sufficient understanding to form a government with long-term survival. Most types of government organization that we know of have failed in the past, except maybe perhaps for the U.S. one, and yet that seems to be in trouble. The best that these organizations have done, such as the Roman Empire, is to transition from one form to another that collapses. That is to say, the nation collapses to a state, such as the Greek city-states, which then collapse to be tribes, etc. And I've written a couple of papers starting to examine this about steering humanity's growth and the growth challenge of the United States. Well, those are the things I'm thinking of for application of the STOE, but of course other possibilities are open also.